In this video, we want to evaluate this integral 1 over 3 radical x plus 1. You want to try this, go ahead and pause the video and see what you can do with it, and I'll be back. This appears like a U-substitution, and I'm going to start by letting u equal to square root of x. And take the derivative, differential here, du equal to, this is square root of x, is x to the 1/2, so I could write this as x, or 1/2, using the power rule, and then subtract 1 from the exponent of x. 1/2 minus 1 is negative 1/2, and then I have the dx here. So let's solve for dx here. Multiplying by 2 and by x to the 1/2, I'll get dx is equal to du. Then I'll have a 2 here, multiplying by the 2, and x to the 1/2. So we want to transform this integral into one involving the variable u instead of x. So this will then be 1 over 3, then radical x is the u, put a u here, plus 1. The dx is replaced by 2x to the 1/2. I put that 2 out in front here. Move this 1 here. And this is x to the 1/2 here, or the square root of x. So replacing the dx by 2x to the 1/2, wind up with this. And then I have to continue here because again I want the variable u, not x, so this will be 2, and then x to the 1/2, of course, is the u. So this will be 3u plus 1 down here, and du. So now we have everything in terms of u. We gotta integrate this using either partial fractions, if possible, or some other kind of integration technique. Since the degree of the numerator is the same as the degree of the denominator, I want to go ahead and simplify this. So let me get rid of this over here, and I'm going to divide. So this will be 2u, and divided by the denominator, 3u, plus 1. So long division here, 3u into 2u will give me 2/3. The u's cancel out. And then I multiply this partial quotient times the divisor. So it'll be 2/3 times 3u will give me 2u here. And 2/3 times the 1 will give me 2/3. And then we subtract here. 2u minus 2u cancels. 0 minus 2/3 is minus 2/3. So the quotient then is going to be 2/3. And then of course the remainder will go over the divisor. So I can rewrite this then as the integral of, so this will be 2/3 here. So I'm replacing this integrand here, 2u over 3u plus 1 by 2/3. And then this will be a minus here, and then it'll be 2/3 here over 3u plus 1. This will be du. Now this part right here, we can do this. We can use another substitution. If I let say u1, u sub 1 equal to this over here, then du1 would be 3 du. So I replace this by that new variable u1, and I'd have a coefficient here of 3 out in front, and this is a 2/3 here. Okay, from out here, this fits over the divisor. So with this extra factor here, if I go to the other another substitution, I get an extra factor of 3 there. So the integral then of 2/3 with respect to u would be 2/3 u. And for this one here, I still have the minus there, and this becomes a natural log. So coefficient is 2/3, and then this extra factor of 3 when I introduce the other substitution, so this would be minus 2/9. This will be the absolute value of 3u plus 1. Plus the constant of integration. And we're pretty much finished with the integration here. It's just a matter of going back to the original variable. So this is equal to 2/3, and then u was the square root of x, the original substitution, minus 2/9 ln of 3, and then u is the square root of x plus 1. And of course this is a positive square root here and a positive 3 in front and a positive 1 added. So I don't really need the absolute values here. So I just put parentheses plus c. So 2/3 square root of x minus 2/9 ln of 3 radical x plus 1 plus your constant of integration. That's your solution. Thanks for watching, and we'll see you next time.